Hello and welcome to another episode of this city building tutorial series in Unreal. Today I'm going to be expanding on our last episode where we made this grid system, and what I'm going to be doing is teaching each individual cell to know about its neighbours. So you can see at the moment when I click on something, all of its neighbours turn red. That's where we aim to get to by the end of the episode. It is a long one and there is some maths and stuff in here, so take it slow, take it easy, and hopefully I walk it through you well enough. So let's get started with altering our grid cell. So from the last video, which I would heavily recommend you go and watch if you haven't watched it yet, because it's going to play into this video a lot, we created just this base grid cell that is just a sphere representation. So when we hit play, you can see that our grid is kind of represented by these spheres. We're going to expand out the logic of that. And the first thing I actually want to do is add in a couple of variables. I want each grid to be aware of its neighbours, so I'm going to add in some variables to store each cell's neighbour, and that'll be its north neighbour, its south, east and west one. This is going to be, I'm actually going to make this a type grid cell, so it's a reference to another object that is the same as itself. Just compile, save that, and then I'm just going to duplicate these so that we have one for each position on the grid. Then so instead of north, this one will be east, this one will be west, and this one will be south. And then we can kind of go through some interaction between the different cells. Why I'm doing this is because I kind of plan on having each cell be dependent on its neighbors that will apply different buffs. So like all buildings will need to be adjacent to a road, so it needs to know if it is adjacent to a road cell. If you put down parks, that's going to increase the value of the neighboring cells, so I want to kind of do that as well, and a bunch of other stuff that allow for more complex functionality in the future. Another component I want to add in is whether this cell is currently occupied, and that's just going to be a boolean. So this is going to keep track of, hey, have we actually built anything on this cell yet, or is it still empty? So a simple boolean will do us there. The other one I want to do is kind of hold what kind of type of building is on this cell if it is occupied. But instead of like looking through the actor types and the actor reference to what is stored in the cell, I'm actually just want to make an enum. For those that don't know what an enum is, it's like a list of different objects that you can create and identify stuff with. So I'm going to call mine building type enum. And then if I just open this up, you'll see it's completely empty at the moment. My enum description is that it stores the type of building this cell is occupied by. And so the list of different things my cell can be occupied by, it can be occupied by a zoned building. So this will be like when I zone out some residential or industry, it will know that this cell has been zoned. We'll have another one that's called placed, and that's when we have a specific type of building like a hospital or a police station that is actively placed on this. And then the last one for now, I mean we might expand this in the future, we're going to make this last one a road. And that's all we need to do to actually create the enum. If we go back to our grid cell and add in a variable, and it's going to be called the occupying type. And then if we just search for our building type enum there, compile and save that. What I might actually do in my building type enum, just create a new one, and I'm going to put this one right to the top. And this one is just going to be called none. So by default, it's not occupied by anything, so the building type is none. That might be just a nicer way to keep track of that. So by default, it's set to none, like so. Okay, and then the last thing I actually want to do is, it would be quite good for the cell to hold a reference to any actors spawned on it, so I'm going to call this occupying actor. This is just going to be an actor reference, and then if we need to do any special functionality on a single building or anything that we're putting down, then we should be able to do that from the cell. The cell will know about the actor that is occupying it, which is good. And in fact, as part of that, I'm just going to go into the event graph and I'm going to create a new custom function or a custom event that is going to be called set occupied. And then it's going to take in an input, two inputs in fact. First input will be it'll be the building type enum, so that'll be passed in, and that will be the new building type. And then the second one will be an actor reference, and that will be our new actor that is stored in this cell. Occupying actor. And then all we need to do actually in this event, we're going to set is occupied to true. We actually do want to make sure that is occupied is set to false to begin with, so that's good. Make sure that's ticked. We're going to set our occupying type to whatever is passed in. In the future, we might want to get this out from the actor that we're spawning in. That's also a possibility. And then we just want to set the reference to the occupying actor like so. And that's all that functionality that we need for there at the moment. The next thing we need to do is set up the neighbors being set. So I'm actually going to make all these variables public so that they can be viewed from outside of this individual grid cell. Well, I'm going to do all this logic from the grid manager, as that holds all the cells in one location. So it should be that tells each cell, hey, this is your north neighbor, this is your east neighbor, this is your west, this is your south. So if we just click on these icons to make the eye appear, and these will be public, so we can do that. And then, yeah, I'm going to open up my grid manager. And once the populate grid is done, this is a function that we created in the last episode. So again, if you haven't watched that, I highly recommend doing that. I'm just going to create another function, and that's going to be populate grid cell neighbors. Like that. I'll save that. And what I'm actually going to do as the first thing I'm going to do here is this grid array that we have. Instead of the variable type being an actor, I'm actually going to make it directly of type grid cell. So yes, we are going to change that. Okay, hopefully that worked okay. It still compiles, so that's good. I might actually just give a quick test run. Okay, yeah, the grid still works. Just so that, you know, the grid manager is forced into using the grid cells specifically rather than just generic actors. So that'll be beneficial to us. And this is where the logic gets a little bit complicated, but I'm going to try and go through this slowly, but feel free to pause the video, rewind, and make sure everything's working all right. So what I want to do in here is I'm going to get out our grid array. So this is the array that holds all of our grid cells. I'm going to do a for each loop through here. And to figure out which is neighbored to which, because this is just one list, a 1D list of grid cells, we're going to actually use some maths and the array index to figure out which neighbor is which. If we look in our grid cell, all these neighbors, by default, they will be set to none, so they won't have a reference, which means that neighboring cell is empty. This is actually a valid thing to have. If I go back to my game and I press play and I navigate over to the corners, all these cells will not have a neighbor past this line. And similarly at the top, there'll be no neighbors past this line. So there are some cells that will have empty neighbors, and that's fine, that's what we want. Okay, so this is where the logic does get a little bit difficult. And to try and ease my explanation of this, I've created this little just list of numbers. We already know that our grid starts, the first element in our grid array is 0, and that is the bottom left of our grid. I can prove this by just breaking the reference to the world offset here, and now when I spawn in the grid, it'll start at 0, 0, and you can see that the first element that spawned is the bottom left. So easy as that. Let me just go back and undo that so it goes back to normal. Right, so to populate the grid of all of its neighbours, we're going to start with the south and the north neighbours because they're the easiest. Basically, if we're at the 10th index of the array, we know we're in this position. Our grid is 10 across, and for the purposes of this is only 4 up, but it would be 10 by 10, so it would go all the way to the top. All we need to do to find out the south neighbour is subtract 10, right? 10 minus 10 is 0, and that is the south neighbour. Very simple. So let's go about doing that, shall we? So we just want to pull this array element off, and we're going to set our south neighbour. Set neighbour south. And then to do that, we know our current index in our loop. We're just going to do a subtraction, and all we need to subtract is the grid size. Like that. That will get us the index in the array of our south neighbour. So we need to get a grid array. One thing you want to be careful of, blueprints do this a lot. You want to do get. So if I turn context sensitive on and I say get, it tries to do get a copy of the element in the array, but we actually want a reference. We don't want the copy. So type in get ref, and then if you untick context sensitive, and if you scroll down to the array section, the utilities array get a ref. If we do this, plug in that integer, and then plug that into our neighbour south and compile that, that's what we actually want to do. I don't know why it doesn't come up in the context sensitive menu, but it doesn't. So just make sure to be aware of that. One extra thing we need to do, however, if we go back to our sheet here, this bottom row they don't have any south neighbours, so we don't actually want to set them to anything. The logic we currently have will just break the program, because if we are currently at index 0 and we minus 10 from it, it's not possible to get an element at index minus 10 here. So we need to do a little safety check. And that safety check is very simple for this one. We just need to make sure that if we do, so we can just use this here. If we just pull this out, and if this is not greater than 0, so if we do a greater than or equals on this integer, and then just do a branch like so, we're actually going to plug the loop body into the branch, and only when this branch is true do we actually set the neighbour. If it's false, we don't want to, because this index is out of bounds and that wouldn't be safe. But that's a very simple way of doing it. Hopefully I was explaining that well enough. This logic is very mass heavy. So if you do struggle, please just drop a comment below. I'll try and explain it in a bit more detail, or I'll just send the algorithms that you need and you can implement them however you want. So that's one of the 4 neighbours done. Now let's just do the north neighbour, which is very similar logic. But instead of minusing, we're going to add. So add an integer to that, and again it is just going to be the grid size that we add to it. As you can see, if I go back to my sheet, the north neighbour for index 0 is index 10. 0 plus 10 is 10, so that's the index we want. Just again, so get the grid array, get a reference out, so get ref. There we go. Plug this index in, set neighbour north, like that. And again, we want to do a check, but we want to do the opposite this time. So we need to make sure that this index is less than, and because this has to be the max of the array, we just want to do length. And we can turn context sensitive back on, like that, compile, save, pull out the branch, this over a little bit, true, and then just plug, and then we want to come down from here. So if this is false, then we try the next branch. If we do a set, so basically all code paths lead to the next step, which is the north step. So let's just grab all those, comment that, and say north neighbor. So hopefully you get what I was doing there. So the index we currently are plus the grid size, which is 10, will get us our north neighbor. However, if we are at the top here, so 31 plus 10 is 41, and that goes outside our index array. So we're just making sure that the index that we've calculated is less than the length of the array, and then that's what we're doing the safety check on. Okay, so north and south are fairly simple. East and west is where it gets a little bit trickier. So let's get into that. So let's start doing the west neighbors first. So everything except the one on the far left is going to have, it's going to be very basic. It's just going to say the current index -1, that is your west neighbor. But we do need to make sure that we're not making these ones on the left, try and put in a west neighbor. So what do you see here that would make that obvious? Well, we know our grid size is 10, and these are all multiples of 10, barring the 0, of course. So that is the way we figure out if our index has a west neighbor. So let's actually do that, because it's a bit of complicated logic. The syntax is a bit strange for this one, so we'll get into that first. So what we want to do is, the first thing we actually want to do is we actually just want to check if our index is equal to 0. Because if our index is 0, then yeah, it doesn't have a west neighbor, so let's just ignore that, shall we? And then the other thing that we do need to check is our index a multiple of 10 or a multiple of our grid size? The syntax for this is actually a percentage sign. So if you do a percentage sign and an integer, like so, make sure your grid size is always plugged into the bottom one, and that your array index is plugged into the top, because the larger number has to be the top value of this. And I'm not going to go into why this is the case, but basically you just want to make sure that this equals 0, like so. That's all you need to do. So this branch will now actually tell us whether this is a multiple of 10, essentially. Is this a multiple of whatever our grid size is? That's what this functionality does. So I can plug these in just for now, like so. Compile and save those. So actually what we want to do for our condition here is we want to make sure that neither of these booleans are true. So if we just do an OR operator like that, and just pull that in and then put that as a condition rather than this, basically now this branch says, hey, is this current index a multiple of 10 or is it 0? And then assuming that both those are false, that's when we actually want to set up our index neighbor. So again, I know this could be very confusing, and I'm hoping I'm explaining it properly. I will be more than happy to go over it in more detail in the comments. I know this video will run a bit long because of all this, and I'm keen for it to not. So set our west neighbor, and then, as I said previously, it's actually just our array index -1. And that will get the array of the west neighbor. Again, just get the grid array and get a reference to get ref. Undo the context sensitive because it makes you do that. There we go. Plug in the index, and that is the west neighbor. Cool, that is west, and then we're doing very similar with east again, with just a small change. So that's the west neighbor. So with our east logic, what we actually want to do is, it's the same as what we've done with the west logic, but we actually want to add, we want to +1 to whatever our index is, and then check if it's a multiple of our grid size. So here, for instance, we'll say 9 + 1 is 10. Is that a multiple of 10? Yes. Okay, then we don't want an east neighbor. Similar with 29. 29 + 1. Is that a multiple of 10? Yes, it is. So we don't want an east neighbor. And then for all the rest of the numbers, we just want to say, hey, add 1 onto your index. That's your east neighbor. Simple as that. So let's actually do that in here. So we want to get down our array index, and we want to add 1 to it to begin with. So we just do that. And then we want to do the little percentage sign, and we want to do that based on our grid size, like that. So if this is true, sorry, we actually want to see if this equals 0, and that's what the branch will be. So put a branch there. If that is true, then we don't want to set up a west neighbor. Again, just bring all code paths so they always flow through the diagram. So we only run the logic if it's false, and to do that, it is simply the array index -1. Get the grid array, get a ref to the correct object. We're going to call set neighbor east onto this one. Plug that in. Remember, this has to be false, so only if the false runs. And then that is actually the end of our loop. We've set up all the neighbors. Just comment that and say east. And there we go. That will work. I'll put some debug stuff later on just to prove to you that this has actually worked. Okay, so before we forget, go to your event graph, and after the populate grid is called, we want to call the function that we've just made. So populate grid cell neighbors, like that. And then that should run. And then let's just check that everything runs when I hit play. Nothing breaks. That's a good sign. No warnings either. Again, that's a good sign. Okay, so we actually want to change some of the logic we've done previously a little bit. Previously, when we're looking to spawn an actor, we're currently just getting our closest position on the grid. It's actually going to be better to us now to actually just return which grid cell is our closest grid cell, rather than just getting out a location. So I would suggest that we alter this function, or maybe we create a new function that gets our closest grid cell rather than our position. So I'm actually going to do that. Let's just duplicate this, and we're just going to call this get closest grid cell. And that way we've already got our logic already done. You know, we're already looping through. It's already, instead of doing the set locations and set positions, if we just pull down our local variables, in fact, we want to keep the closest distance one, but we can get rid of the closest position. So let's just get rid of all that stuff. Just make sure we're carrying on there. With our closest position, yeah, we won't be returning out our return node. Again, we're not actually outputting a position anymore. We want to output a grid cell, or a reference to a grid cell. So object reference there. Compile, save that. So yeah, just clear out your closest distance variable, add in a new, and this is just going to be a base integer. It's just going to be the index in the array of the grid cell we're going to send back. by default, it's going to be 0. If this returns true, then we're going to set our array index to be the array index of the loop we're going through. And for our return node, get the grid array, get ref, get a ref there, array index, plug that in, and then that is what we return. So that's a fairly quick change. The reason that I duplicated the grid position one is because we probably do want both this logic at some point, so we might as well keep both rather than just getting rid of one. Right now, so if we go back to our play controller, what we can actually do, because we spawn a building at some point, once this actor is spawned, if we get out our grid manager in here, so we'll do it the same here, just get actor of class, and it's going to be the grid manager. That's all you need to do, and then the return value, drag that out, and this is where we're going to call the function that we've just used. So get closest grid cell. So we can just use the placeable actor transform that we're using. So if we just get actor location on that, plug that in, we could probably make this a bit more efficient in the future. But for now, I think this will do a job. So now we've got the closest grid cell. The purpose of this is to tell the grid cell that this grid cell is now occupied. So the function we created right at the start, so we pull out the grid cell and we call set occupied like that. By default for now, we're just going to say we've placed down a new building, and the reference, just plug in the created actor. Save like that. And now when we go to game and we run and we click and we put down the building, our grid cells now know what they are currently occupied by, which is exactly what we want. So what I'll do is I'm going to create a quick debug function just so we know that this definitely works and all the neighbors are set up correctly. I'm going to make it so if I plonk a building down, that the north neighbor is going to change color, the east neighbor will change color, the south neighbor will change color, and the west neighbor will change color. Just on these basic spheres that we have currently, just so we've got a nice bit of debug, and we know that our stuff actually works. Okay, so I'm just going to say, just create a new custom function that we'll just call debug show neighbor occupied, like that. And all this is going to do is get our sphere, and we're going to set our material. We're going to set our material, and we're just going to set it to be the red material for now. And then in our set occupied state, we're going to get our north neighbor, and we're going to call debug show neighbor occupied. I'm going to do this for each of the neighbors just so we can show that. Debug show neighbor occupied, west, south, debug show neighbor occupied, debug show neighbor occupied, plug this in, just make that as flat so it doesn't look too horrendous. So if I hit play now and I place something down, okay, we've got two that are not working as intended. So let's try and debug that a little bit. So I did do a lot at once, which is probably why it hasn't all gone to plan. Okay, so for north, I mean, this is immediately obvious. I forgot to plug things in properly. So I actually want to drag that one into the neighbor north, and then our array index into our target. If we compile and save that and we run it, okay, cool, we can see 3 now. It's not the 3 I would have expected, actually. I would have expected that one and that one, so maybe I've got maybe north is actually that way and south is that way, rather than what I've been doing, which is north as that way and south as this way. Okay, maybe that's part of the problem. Right, so debugging for a little bit, I have found what I did wrong here. What I've done here is I've actually done the true and the false the wrong way around. So we only want to set our west neighbour if this condition is false. If it's true, we want to continue. And I actually did a subtraction here instead of an addition. In fact, no, it's not in the west one, it's in the east one. I did a negative when I should have done a plus. So if I bring that down and I do an add, like so, and put that in. Compile, save that. Go back, and hopefully now it should all be working. There we go, you can see all 4 are highlighted. If I do it over there, that's good. If I do it at the edges, I'll get an error because one of them is null, but it will actually show the correct things are all showing up. And there, so that's a good foundation for us to go forward into the future. And next time I'm hoping to get started on the roads. So as I mentioned at the start, the reason I'm doing all this is so that when I put a road on this tile, all these red tiles I can now put actual buildings on, which will be super useful. Okay, right, thank you very much for watching. I hope you enjoyed the video. Please drop comments below if you have any questions. I know that was a bit of a heavy one. And if you're enjoying the series, please subscribe. That always helps me out. Thanks again for watching. I hope to see you in the next one. Bye for now.